Hi, folks. Thanks for joining me. Circles have been a part of geometry for thousands of years. But what if I asked a radical question? Is it possible to do geometry without circles? In this video, I'm going to show you how you can do geometry without circles using a special tool. Now, let me share my screen with you. I suspect almost everybody would be familiar with a tool like this one, a ruler. And you can see this one has markings on both edges and some interesting information in between. But what really excites me about this tool is if we turn it over, more information, of course, here, here, and here. But now we have two parallel unmarked edges. Collectively, this is known as a parallel straight edge or a double straight edge. And so what does that allow you to do? Well, it allows you to easily draw sets of parallel lines. So how can we do geometry using this tool alone? No need for a compass, no need for circles. Well, I'm glad you asked. So let me show you a classic construction using this double-edged straight edge or parallel straight edge. Okay, so suppose I have a line segment and a point not on the line segment. A classic construction from geometry, you see it in school all the time, is to construct a line through C that is parallel to the segment AB. So how can we do that with this double or parallel straight edge? Okay, so let me show you some moves and we can work through it. So first thing I'm going to do is to rule or construct a line segment joining the endpoint A with the point C. Secondly, I'm going to put one edge on the point A and rule a line. And then I'm going over to the other side of the straight edge and rule a parallel line. Okay, so I'm going to repeat that process by moving my parallel straight edge and ruling another line. Okay, so we've got a whole bunch of points now. So let's label some of them. Let's call this one D and this one E. Okay, so you can see we've got a triangle AEB. Now, because I've just ruled these parallel lines, the distance AD is going to be the same as the distance from D to B. Same with these two things. This line segment is going to be the same as this line segment. Okay. All right. So how can we get this parallel line going? Well, one way is to draw a set of line segments called Servians. So I'm going to connect E with D. I'm going to connect C with B. And lastly, I've got a new point here. Let's call that F. And then I'm going to connect A with F and extend it to hit this edge here or this side here. All right, there's my last point. So let's call that G. Now, believe it or not, CG is parallel to my original line segment, AB. So let me draw that in. Oh, I should have that the other way, of course. Let's do that. Okay, so it looks parallel. Okay, it's pretty good drawing. But why is it true? Well, essentially, the triangle ECG is similar to the triangle EAB. So this angle and this angle are the same, and therefore these two lines must be parallel. Okay. So just with two parallel straight edges, I was able to construct this parallel line. And it's not just this particular construction. You can use this kind of tool to do all the problems that you see in high school geometry. So next time you see a ruler, flip it over. See if it's also a parallel straight edge or a double straight edge. If it is, you can get experimenting with these kinds of geometrical constructions. No compass required. Bye, everyone. See you.